Hello friends, in this video we will study about the various types of serial data transmission schemes. So let us start with our topic. We know that whenever the computers and microprocessor they communicates with the input-output devices or the peripheral devices, this type of transmission or communication between them, it can be of two types, like parallel data transmission or serial data transmission. In parallel data transmission, all the bits of the data which are to be transferred between the two components, they are transferred simultaneously. Means if like we want to transmit 8 bits of data, then all the 8 bits of data, they will be transmitted simultaneously. Whereas in the case of serial data transmission, if we want to transmit 8-bit data, then one by one the bits are transferred. It means that when one bit is transmitted, then second bit is transmitted, then third bit. In this way, all the 8 bits will be transmitted one by one. Okay, means at a time only one bit is transmitted. So if we draw the diagram for the parallel and the serial data transmission, it will be like suppose this is the sender and the receiver. Sender is going to send the data and receiver is going to receive the data. So in the case of parallel data transmission, all the bits are transmitted at the same time. So here, if we are having 8 bits of data, then all the 8 bits will be transmitted simultaneously. Whereas in the case of serial data transmission, suppose that first one bit is transmitted, then second bit is transmitted, suppose it is 1, it is 0, then again we are having 1, 1. So in this way all the bits will be transmitted, only one bit is transmitted at a time. So this is the case of parallel data transmission, whereas this is the case of serial data transmission. So in this video, we are going to study about the various types of serial data transmission scheme. Whenever the microprocessors and computer or whenever we have to transmit the data for over long distances, then we use serial data transmission, because in serial data transmission only a single line is required to transmit the data, whereas in the case of parallel data transmission, whatever number of data we want to transmit, that number of lines we required. So more number of lines or more cables are required to transmit the data, whereas in the case of serial only single line is required. So whenever we are transmitting the data over long distances, we prefer serial data communication. Okay. Now when we are studying about the serial data communication, so in the case of serial data communication between the sender and the receiver, the main requirement is that there should be some coordination between the receiver and the sender, because when the sender is sending the data, how the receiver is going to know that from where the data is starting, where it is ending, and what is the speed of the data transmission. So there is a need for the coordination between the sender and the receiver. Okay, for example, So for all these things, there should be some coordination between the sender and the receiver, so that the receiver should know that when it has to start the transmission, when to end the transmission, when one particular bit or byte ends and another bit or byte is beginning, means from where the data is starting and where it is ending. When the receiver capacity has been exceeded, means if suppose that sender is sending the data but the receiver capacity has been full, it cannot accept more data. So how this all these things get to know between the receiver and the sender? So there is a need for the coordination between the sender and the receiver. So for the coordination, there is a requirement between synchronization. Okay. So for all these things, there means if we want that there should be a coordination between the sender and the receiver, they should know about all these things. There is a need for synchronization between the sender and the receiver. Okay. Now for this synchronization between the sender and receiver, there is a protocol has been defined. A protocol is a thing like a protocol, we can say in our day-to-day language, they are the rules. So rules are defined for the transmission or the coordination between the sender and the receiver, and these rules are decided or protocol is given by some association, that these rules should be followed whenever data transmission is taking place between two devices. Okay. So a protocol, it is going to define all the rules between the sender and the receiver. Like when two PCs, they are communicating with each other and one PC is sending the data to another PC. Now how this second PC is going to know that from where the data is starting, where it is ending, what is the speed, and when its capacity has been full. So all these things, they are defined through this protocol. Now, as I have said that there is always a need for synchronization between the sender and receiver, so that this whole process of data transmission, it can work in a proper way. So for this synchronization, there are two types of serial data transmission which are defined on the basis of the synchronization, and these two types are known as the synchronous data transmission and asynchronous data transmission. These two types are also known as the types of serial data transmission schemes. So we are going to study about these two types in detail. Okay. Now these two types of data transmission, synchronous and asynchronous, they are defined on the base that in the synchronous data transmission, the data transmission is taking place in the form of two signals. One will be the signal, means the data which the sender is sending to the receiver, and another signal is the reference signal, or we can say the clock signal. So that clock signal will define that from where the data is starting and from where the data is ending. So the starting and the ending of the data will be defined by another signal which is sent along with the data. So in the synchronous data transmission, we can say that we are using a clock signal to define the starting and end of the data. Whereas in the case of asynchronous data transmission, no such clock signal is used. We are sending the data, and along with the data we are sending some bits, or some data is also sent, and that data will define that from where the actual data which we want to transmit, that is a starting, and at which position it is ending. So along with the signal we are sending that information, so no another signal is used. So that is the difference between the synchronous and asynchronous. In synchronous we are sending two signals, one is the clock signal and second is the data, whereas in the asynchronous data transmission we are sending only a single signal, and that signal will contain the data and also the start and the end of that data. So now let's study these two types in detail. First we will start with the synchronous data transmission. So in the case of synchronous, as I have said that we will use two signals. So this method uses two different signals. One signal means a pulse on one signal line indicates when another bit of information is ready on other signal line. So there will be two signal lines, and a pulse on one signal lines means the clock signal that is going to define that when on the other line the data is available, that information is available. So here I have written a pulse on one signal line indicates when another bit of information is ready on the other signal line. Okay. So in synchronous transmission we were using two signals, and the data that we want to transmit, that data is encoded and it is sent on one line. So suppose these are the two lines. Okay, so on one line we are sending the data. Okay, and a periodic pulse of voltage known as clock is put on another line. So on another line we are sending the clock. So when this clock will be a periodic pulse of voltage, so that periodic pulse, it is going to indicate that when the data is available on the second line, and it is put on another line that tells the receiver about the beginning and the ending of each bit. So this clock pulse, it is going to indicate that from where the data is starting and from where it is ending. So the beginning and the ending of each bit is indicated by this clock, and this clock will tell the receiver about it. Okay, so if this is the sender, this is the receiver. So in between the sender and receiver there will be two lines. On one line we will send the data, and on another line we will send the clock pulse. Let's have a view on it in detail. Suppose here I am drawing a clock pulse. So this is the green line, it is our clock pulse, it is a periodic pulse of voltage. So here you can say it is a square wave. So it is our clock pulse, and the data which we want to send, that is shown by the red line, that is our data. Here we have sent an 8-bit data. So 8-bit data will have 8 bits starting from B0, that is bit 0 to bit 7. Okay, so first of all you can see here it is low here, so that will be 0. Bit number 6 is 1, 1, 0, 0, 0, 0 and 1. So if we see this 0, 1, 1, 0, so that will be 6, and this is 0, 0, 0, 1, that is 1. So the data which we have transmitted here is 61H. Okay. Now this is the clock pulse. Now this clock pulse, it is having an end which is like the falling edge, and the other end is the rising edge. Rising edge means when it is transmitting, means the transition is taking place from low to high, that will be called the rising edge, and when the transition is taking from high to low, that will be called the falling edge. So at this falling edge, at the falling edge, the transmitter is going to send the bits, and on the rising edge, the receiver is going to read the data. So that is how this is the one clock cycle, means this is the one clock pulse. So in this one clock pulse, we are having falling edge also and rising edge also. So at the falling edge, transmitter is going to transmit the data, and at this rising edge, the receiver is going to read the data. Again, we are having bit number 6. At the falling edge, the transmitter is going to transmit that bit, and at the rising edge, receiver is going to receive that bit. Again, in this way, the data is transmitted, and the receiver is going to get the information that from where the data is starting and where it is ending. So starting is the part that as this rising edge, it is going to read, and it is the starting where the transmitter is sending the data. So in the case of synchronous, two signals are transmitted. One is the clock pulse and second is the data. So we can say that here at falling edge, okay, so all the information that from where the data is beginning and where it is ending, all the information is there with the clock pulse, and these falling edge, rising edge, these are related with the clock. So in this way, a synchronization is made between the sender and the receiver. If we draw the diagram for the synchronous transmission, that how this transmission is taking place, then suppose this is the transmitter and this is the receiver. So this is how we can represent the synchronous data transmission. We are having a transmitter and a receiver. Transmitter is sending the data along with the synchronization pulse, that is sync pulse, and that pulse is the clock. Now this clock pulse is common between the transmitter and receiver, so both are synchronized through this clock pulse. Clock pulse will indicate that from where the data is starting and at which position it is ending. So that is how we represent the synchronous data transmission. Now let us see that what are the advantages of this synchronous data transmission. The advantages of synchronous data transmission is that lower overhead is there. Overhead means like we are transmitting the data, and along with that we are transmitting the pulse also. So all the data is transmitted, and clock pulse is there, beginning and starting is there. So only we are transmitting that data. No other information we have to transmit. We just give the clock pulse that is common between the transmitter and the receiver, and only the data is to be transmitted between the two components. So there is lower overhead, means collection of data is less, and we don't have bulky there. So if lower overhead is there, so greater output we are getting. So that is another advantage, that we are getting greater output as compared to the second type, that is the asynchronous data transmission. Now talking about the disadvantages. The disadvantages of synchronous data transmission are that it is more complex than the asynchronous one, because here we have to transmit the clock pulse and the data also. So clock pulse generation, that will make the process more complex. Also hardware is expensive for synchronous data transmission, because two lines are required, for one for clock and one for the data. So now let's come to the second type of data transmission scheme, that is asynchronous data transmission. So in the synchronous data transmission, we studied that two signals are required. One is the clock pulse and second is the data. Whereas in the case of asynchronous, only one signal is required, and that one signal will contain data, along with it the information that from where the data is ending, what is the beginning and end of the data, that is also contained in that signal only. Okay, so asynchronous, it requires only one signal. So the asynchronous data transmission, it uses only one signal, and on that one signal the receiver is going to use the transitions on that signal to figure out the transmitter bit rate, which is also known as the auto baud, and the timing. So on that one signal there will be different transitions, and the receiver is going to use those transitions to determine that from where the data is starting and from where at what is the end of the data. And the baud rate, that is auto baud or the transmitter bit rate, this is a kind of term which is defined in the case of data transmission. Baud rate means that how many bits are transmitted per second. So if you the receiver is going to use those transitions to find out that what is the transmitter bit rate, that is at what speed the data is transmitted by the transmitter. So according to that bit rate, it is going to determine that what is the beginning and what is the end of that data. So all the information is contained in that one single signal only. Okay. So in the synchronous data transmission, we studied that a clock signal is there and the data signal is there. So that clock signal is external. So we can say that in the synchronous transmissions, they use an external clock. Whereas in the case of asynchronous, because a pulse from the local clock, it indicates that when another bit is ready for the transmission. So it means that when one data bit is transmitted to the receiver, another data bit that will be indicated by a local clock. So the receiver and transmitter, they are going to have separate clock pulse for them, and that separate clock pulse will indicate that when another bit of data is ready. Okay, so we can say that the difference between synchronous and asynchronous, another difference is there, that in synchronous data transmission, the clock pulse that is provided, that clock pulse is external, whereas in the case of asynchronous, it uses special signals along the transmission medium, and these special signals, they will act as the local clock for the transmitter and the receiver. They will have separate clock pulses for them. Okay. Now if we draw the diagram that how this data is transmitted in the case of asynchronous, it will be like, so here we are transmitting the data which is again 61H. Okay, so here because we are transmitting along with that data, we are transmitting two bits which are indicating the start and the stop bits, indicating the beginning and the end of the data. Now here we are having two transitions, that is the transition of the start bit and the transition of the stop bit. So at this, so at this falling edge means at when this start bit is transmitted, the transmitter uses an internal clock to determine when to send each bit. And at this detects whenever this receiver, it detects the falling edge. So receiver is going to, so when this transmitter, it has used its internal clock, it has determined that it has to start sending the data. It will first send the start bit. Okay, now when this when the receiver it detects the falling edge of the start bit, it determines that the next bit will be the data. So that will be the starting of the data. Now when it got the rising edge of the stop bit, it will get to know that at this position the data has ended up. It has got it 8-bit data here in between the start and the stop bits. Okay, so you can see that in the asynchronous data transmission, the transmitter is also using its internal clock and the receiver is also using its internal clock. So there are separate clocks, there are separate internal clocks of the transmitter and the receiver, whereas in the case of synchronous data transmission, there is an external clock which is common to both the transmitter and the receiver. So if we draw the diagram for the asynchronous data transmission, it will be like, so in the asynchronous data transmission, suppose this is the transmitter and receiver, they will have separate internal clocks of their own. There is no similarity between these clocks, no commonness is there. So when this transmitter, it will use its internal clock to determine that where it has to start the transmission. First it will send the start bit. Now when the receiver, it uses its internal clock to find out the falling edge of the start bit, it will use that data, it will read that data, and again stop bits are there. Now for start bit, there is only one bit is used, but stop bit we are having two bits. So if we are having 8-bit of data, along with that 8-bit, one bit is for the start bit and two bits are for the stop bits. So total here we are having 11 bits. Okay, so whenever data is transmitted using this asynchronous scheme, we are going to transmit 11 bit of data. 8-bit will be the data, 1 bit is the start bit and 2 bits are for the stop bits. Now let us see that what are the advantages of this asynchronous data transmission. The asynchronous data transmission is simple and it doesn't require synchronization on both sides, because both sides they are having their internal clocks separately, so no synchronization is required, and this method is simple also. We just need only one line, and on that line only, along with data, we are transmitting all the information. Now, as there is no synchronization in this method, so timing is not so critical in this case. Timing is not required, and as timing is not required, it will the hardware requirement is less. Because no separate clocks are required, so internal circuitry can be used, so timing is not critical. Hardware will be reduced, and hardware is reduced, so we can say that this method is cheap. So another advantage is that its setup is very fast, and because less hardware is required, so we can set up this type of transmission very quickly. And talking about its applications, it is used where messages are generated at irregular intervals, because no timing, no synchronization is required, so we can use it in the applications where the messages or where the data is generated at irregular intervals. So these are the advantages of the asynchronous data transmission. So in this video, we studied about the types of serial data transmission schemes. The two data transmission schemes are the synchronous data transmission scheme and the asynchronous data transmission. And then we also studied that how the data is transmitted in these two schemes, also their advantages and disadvantages. So I hope that this topic is clear to you. Thank you.